Hello, hello. Trying to automate starting a stream. So we started a stream. You also have somewhere specifies that what's called DNS or something is available, so you can scroll through the stream back and forth. So it doesn't have to be a live. You can see what's previously been recorded. That's okay. I think it's a default option, but early on I was playing around with it and forgot to put it back to enable. So record this onto our machine as well, and we start a virtual camera, which then allows me to have the stream on a Zoom video. So this video is actually OBS virtual camera. You can hear me through it as well if you want to. Should be the same as I should be hearing myself. No. Why is my system microphone is the live cam studio? I don't want to use that microphone at all or ever. I have the stream on another screen. So this is for you to join in if you like. Go on there. And we have the Zoom a window sound coming through here as well. So that's that. Clearly. Right, and I have the monitor of the Zoom window monitoring it in OBS. And I can monitor my sound as well. That's a bit too loud. Why? Yeah, see, noise goes in when when this when the sound haven't died out. So when it's still, so that's it. So now you can't hear it. It's weird. I don't understand how it works. I have to keep testing it, but yeah, I want to monitor off. Close that. So there is that. Hello, hello. Someone joined in. Still posting about it on LinkedIn. I was thinking doing LinkedIn events, but they are much more. The user interface is much more cumbersome. So don't actually know how to do it properly. I don't know if there's a good way of doing it or not. So I'll get back to the site and the web apps and the APIs and the site. Just posting this quickly. And LinkedIn also keeps changing my link. So if you put the link in a long link in the post itself, it changes it to something weird. It's not great. Um, Bluetooth headphones to work as well. I think if I just turn them on, correct. No, those are the wrong ones. They look the same. Both these Jabra headphones, and they're very right. It just see if it's the right. So they automatically selected as well, which is great. Anyway, so the idea is that you can provide feedback or just have a chat about anything biomedical engineering, biomedical data science. Hopefully, it's quite ambitious, isn't it? So just make it as interactive as possible. We were chatting to a couple of people before. I think said they want to potentially join in. I can't find them. Give me a second. By the way, let me know if you tried the website. Just get out of. Oops. Just get out of full screen here. Yeah, that's what the website called. We are working on this new API that hopefully will be available in a bit. We did it earlier this morning. and hopefully we'll finish it today. Or is it being too ambitious? I don't know. We can try. Trying to find. Yeah, there we go. We just invited some people to join in. Right, someone was making a comment. A LinkedIn friend was making a comment about this tool. It's the noisy sinusoid neural network prediction. Doesn't fit my screen. Right, so essentially, I actually popped a question into ChatGPT, whatever, not ChatGPT, the other one, the Bing Chat, which is supposed to be ChatGPT. Essentially, the question is it possible to input a periodic function into a neural network as sum of the activation, or consider time as non-linear input, something periodic instead? And the chatbot is answering with, I don't know if I'm allowed to show it over there, but it actually gave me a few papers, which are actually more interesting than what the chatbot has to say. One of which has an interesting figure. I don't know if I'm allowed to show it. I think it's a Creative Commons figure. So it's this paper here from Japan. It's quite a negative title, which is a bit unusual for academic papers. Most of them are like, we can do anything, everything. Normally they're very positive. So they cover some of this activation function, which actually we had a similar example in LabVIEW that I remember playing with a while back. So potentially we can bring it up and try it out again. What's this window? They had this interesting semi-periodic nonlinear. Yeah, so they're putting essentially different functions into a neural net, trying to predict them. Loss. Right, and there are different algorithms that supposedly one is performing better than another, which is great. But yeah, this is some supposedly realistic data. A prediction of Wilshire 5000 index, and you can see one prediction made this and the other one prediction made that, and yes, that's a very very significant difference. But I'm quite confident because of, putting this window into your training set or whatever it is you do. Yeah, the window will determine the outcome. How they use that as a test set. That's interesting. So they use all of it as training and all the last bit as test set. It's really bizarre. Like, how would it? Because could have had another prediction that it will go back down, like it was back in 2009 or something. Based on that, if you just make this, it should be down here. If you just made a simple prediction of what it was, same time, whatever that many years ago. So I don't know how this makes any sense. So there's obviously a lot of assumptions. This one seems to rely on the, so the training probably would have been just up to 2017 or something. So then it would make sense if you just show that like a linear continuation and just show that yes, it will predict something like this with an error margin there. Interestingly, the error margin for the prediction in blue is much smaller. So question is why is the confidence level higher? I don't know. Well, and why do? But yes, a very interesting thing. So just in this simple thing, like the questioner was suggesting that we should not use the time series or something. And yes, for predicting a sinusoid, I don't think you will never. I don't think it's a good strategy to use to feed in time series. You would just feed in, the frequency, because if you know it's a sinusoid, if you know it's a periodic function, then it will just feed in, the frequency domain, and then the prediction will be much better. So I think there was a bit of a, I don't know if that's what the question is. Then have to clarify that I'm not suggesting that a noisy sinusoid should be fed into a neural network like as such. You probably have, if you knew it's a periodic signal, then you'll probably just feed your frequency domain. So essentially, the the frequency of that function. And by the way, we could have added the frequency domain into it, as in the option to choose your frequency of the sinusoid, just as another. But yes, it's a sinusoid of a specific frequency. First, we could probably extend this to up to like 50 or even the full 100. It doesn't really matter. Well, oh, it does matter. I'm saying it doesn't matter from the algorithm standpoint. The API would have still worked. Just look at the YouTube studio. It makes all sorts of silly mistakes, does it? Let's see the chat. It says live chat have moved. What live chat has moved? It's like what moved? All right, now I can see it. Yeah, my CPU going mental. I don't know if for the live streams I should limit it so there's less noise. Anyway, so let's get back to. So normally we test the site in some sort of random fashion. It's like I don't know if that's what the unit unit testing does as well, but this this is a fuzzy logic thing that will show its prediction. It's not prediction, it's a detection. So it's a detection algorithm, a identification algorithm, whatever you call it, and it will display here the detection error in well, not quite red. What color is that? We'll say red, and the number of unknowns. So now they're sitting at 0, and as you make the noise larger, it it's still not making any mistakes, but now it's starting doing more mistakes. So the percentage of unknowns is jumped up to above 60%. And I already mentioned it like multiple times, but just for myself because I'm trying to understand it better. And what does it actually mean is the fact that with different, so square is being detected at the same noise level. Square is essentially easier to detect than, for example, so this is with square. You need to wait until it kind of stabilizes because it needs certain number of iterations before it stabilizes, and it's back to that 60%. And if you choose a left triangle, for example, it's essentially the percentage expected to go up, because essentially a triangle in this type of setup with that much noise is harder to detect, so it's making way more errors. So I don't know, for a human, I guess you can, I don't know if you can see the triangle. I don't know if I can because I've been looking at it for so long. But the algorithm can do it at a lower accuracy, so higher error rate. So sometimes it says, I don't know what this is, and some other times it confuses it with a different, with a square or a right trapezoid, where actually what's being fed in is a left triangle. And as we reduce the noise, this detection error and percent unknowns should go down. So at this noise level, it's not making any mistakes whatsoever. And now it's doing some, but probably would not be as high as before because um, the noise level is below 1 and the signal is 1. Interestingly, ages ago still, remember someone said that actually you could use noise to actually improve detection. So for example, with the simple square, if you know noise, the idea is that If with no noise, the amplitude is 1, and when you add noise to it, the amplitude is going actually higher. So actually, in theory, that if you're doing some sort of averaging, it should be easier to detect, because the more noise you have, the higher the amplitude. But then, which kind of makes sense, but it doesn't, because it doesn't. If you left it at 10, then it does. Then you say, okay, this bit, actually the amplitude of the signal is higher. That was the argument. But I don't think whoever made that post or something actually considered the signal to noise ratio that becomes lower. So in this case, we have a signal to noise ratio of it's like 100%. And in that case, I don't know if you can see it much lower. But it is an interesting concept, the fact that I didn't realize that with no noise, the maximum, the peak amplitude is 1, and with noise, the peak amplitude of your signal seems to be going up by 150%, by 50% to 150% instead of 100%. But an interesting concept. But this tool, we could obviously improve quite a lot of things with it. We could, for example, ask it to stop generating. that would be handy, because this is one of the only tools that just keeps running for forever. It doesn't stop. I think the site, the URL will just time out. I think it's to do with the settings of the browser, but I'm not 100% sure. So we covered the neural net, noisy sinusoid prediction. Let me know if there's any questions, but I probably misunderstood the original question. But what it is. Yet that person is not available at the moment. So that's that. There's someone mentioned the noise. If someone was also asking what would best noise removal for EEG. So I can go on and on about that. We have some relevant tools for it. So we have the denoise, which is probably, so it's a discrete wavelet transform. You have to be careful with it, because sometimes it might just do all sorts of funny things. It might just work for one type of so it's a wavelet. It can be either discrete or non-discrete, which, say in this case, doesn't make much difference. Yeah, it would be good to test these things like side by side. In this case, so in the time domain, it looks like it's doing a fair job removing noise. Reality is it's just getting rid of some of the higher frequency components actually. So it really depends if that's what you want or not. Because maybe that's not what you want. And also address noise in EG by other means. So we have lots of EG tools on the site. Probably should start grouping them by EG, ECG. But then a lot of the concepts are, yeah, I'm not sure what will be the best way of grouping them. We have also the synthetic EG, so that can address some noise issues as well. So for example, in some cases we might consider low frequency as noise, so we might want to suppress it either by making the bandwidth wider, so it gets rid of this peak there for the low frequency component, or we might just change its amplitude. If you had What if you had all the amplitude at its so say you started off something that actually looks like inverse F noise. So another noise. Yeah, because we're talking about noise, so there's some examples of noise. So you have your standard uniform white or Gaussian white. This type of noise, if we have some sort of signal in the mix, let's say the increment as there is 0.2, probably should turn back to 0.1, but you can then manually enter the number that you want. But in this case, so uniform white, we have noise amplitude of 0.5, and then the sinusoid amplitude is 0.5. That's the frequency of the sinusoid. You can select something else if you like, and you can see that signal is very easily detectable both in the time domain and the frequency domain. I think it's kind of same for Gaussian. I mean, there's a slight difference. Yeah, the SNR can actually add an SNR a metric in here, because we know what the signal frequency and we know the amplitude. But then we can make a measurement of and that's power spectral density. But the point is, when you go inverse F, that signal, I mean, it's like if you know about it, it's still there, but it's much harder to detect. So again, this is your uniform white, this is inverse F, and this inverse F, in the frequency domain looks a lot like like what we have here, this type of shape. I don't know if it's exactly inverse F or not, but so you can start like, so when you modeling, when you synthesizing, you have your synthetic EEG generator running. You could start from something that looks like an inverse F, and then start. So say if we left the power at what it is and started changing the bandwidth. So say for delta we could leave it very wide. So for beta, hi Kumar, how are you? For beta we could have it, so say in something like sleep, eyes open, eyes closed, we'll have a change like this. Hey Kumar, by the way, my thing is now set up. I can show you that the stream goes, the sound from Zoom goes into the YouTube stream. Just so you know. I think that's what it does. I can yeah, I don't know, did you say anything? But yeah, anyway, the Zoom, the sound from Zoom should go into my YouTube stream as well.
Hello,
Ah, yeah,
audible?
now I can hear. How are you? Can you hear me all right? Remove this. Yeah, I can hear something coming from your microphone, but sorry. Uh, can you hear me in Zoom as well? That's weird. Wait, what microphone am I using? So I have to check my. Yeah, NVIDIA broadcast. That's weird. You probably can hear me now, but
I can hear you in this live
delay. And
YouTube
can you?
live, but can't hear you through Zoom.
And how about now?
Let me have a check.
No,
Just
cause
say something.
testing,
No,
1, 2.
in Zoom you're not audible, but when I click it on
Oh,
YouTube, you're audible.
and now it should be on Zoom as well, cause it's the microphone. Now you can hear me in Zoom as well. That's super weird. Yeah, it's like some things work. You can use them in multiple places.
No,
Like no,
can't hear you in Zoom.
because I can see my Zoom thing like jumping around. The microphone is jumping around when I speak, like here. It's weird. It should be the same microphone. Yeah, I can see the microphone is jumping around. How come? That's yeah. Zoom fail. put it to. I can hear you as well. So, and yeah, I was just saying that.
Now, yeah, now it's fine. Now I can hear you.
Okay,
In
yeah,
Zoom.
because I could
No,
see.
yeah,
So
yeah.
I could see
Now
my
in
my microphone thing going up and down
Yeah,
like
so
like this.
there is this setting. In that setting, you can say that for me, those who are taking on Zoom, so when you click on that microphone section, you have a setting same as system, right? So we
Uh,
have to click on that.
yeah, but I don't want to. That's my webcam camera, and I don't want to use it because it's the webcam mic, and I don't want to use it because
Uh-huh.
it's a really bad microphone.
Okay, okay. No, but now it's fine. You can continue now.
Okay, right. No, because I could
Yeah,
see the greeny thing in Zoom jumping up and down all the time, but I don't know what happened.
right, right.
Oops. Oh, yeah, and I was just saying that the I was just playing around with it, but essentially where is it? The OBS is now streaming. So what's in Zoom? Like when you talk, yeah. So I can hear your microphone is going into the stream, into the live
Okay,
stream as well. So hopefully
okay,
it's okay. I just have to let you know if like I can remove it from here, but then I can still hear you. So you'll be
okay.
like a producer talking to my ear, but but so it's up to you.
Gotcha.
But yeah, I was trying to make these things more interactive because I tried both, and one is like super bizarre. Because then, like, we had this interesting conversation, I think, with you, and I think you were like,
Yeah, I viewed that
yeah,
conversation.
yeah, and your sound, and then it sounds like as if I'm just talking to myself, which which I'm okay with. But obviously, it's much more engaging if you actually have someone to talk to.
Yeah, so like the last time I was wondering, like, say most of the people were for the EEG, lots of work is done on noise removal and artificial removal, right? So why we can't come up with some new algorithm which will help us in removing online noise thing?
Right. Well,
So
yeah,
for say for the
yeah,
moment, like when you go for this Mobi thing, mobile brain body imaging, so there you need to have this online algorithm that removes I mean real time noise from or the artifacts from the EEG signal recording.
right. That removes, so well, because you then assume that you know what your signal, what your noise, and you know exactly, and there is a clear. So if you plotted them on like a distribution of both, then you have a clear separation on whichever parameter you're looking at, right? Well,
Hmm.
then you can, yeah, then you can easily clean it out. It's just that sometimes um, you will have your signal in the region of the noise. Like, so say if you look at frequency domain, sometimes you so say you might normally assume that the slow frequency component, you might want to just get rid of it, but in other times it might actually be helpful to look at because it say might indicate when the patient is moving, and you actually want to know that, for example, or you actually might assume that they will have a slow wave component in the EEG, like during sleep, and then that slow wave, you know, band in the the frequency band, you actually don't want to filter it out. So how do you? So essentially, when you're looking at the signal, the question is like, how do you know what's
What is the noise, and then like
yeah,
what's your main signal?
and how much
So
they overlap. So if you plotted, say, you look at certain parameters, so your
mhm.
frequency or your so what's the other things we were looking at, the power, or I'll just close this too. They're not really well. No, actually, they are relevant. Yeah, it's all kind. I was thinking like grouping the tools into like ECG and EEG, but then I thought you can't actually do that because a lot of the things are, yeah, I don't know how would you group it because they kind of all interdependent kind of thing. But say if you had your um, so yeah, this is actually a good example, like fuzzy logic. So this is say you had some sort of signature in a signal that you're trying to detect. So it's like in epileptic seizure, for example, uh, or there would be other examples. Or I think you mentioned someone was talking about evoke potentials. So
ERPs basically,
yeah,
right?
ERP. Yeah, so say you have a visual response and you're looking for some sort of like a specific signature. Well, it won't look as simple as that, but you will have some sort of shape that you're looking for, right? So then, well, then yes, if your signal to noise ratio is high, then you can essentially, yeah, with like a fuzzy logic. I don't know if you ever looked into like fuzzy logic or something. It's
No,
essentially
what's that?
another.
Like fuzzy logic? What does it mean?
Oh, it's like it's probably one of the first AIs or machine learning, whatever, that were developed. Like the first paper was back in the 70s or something. I was actually It's actually interesting because I don't have much description in here. I always assume that that you can just like Google it and stuff. Actually, yeah, for this tool I actually did use a Bing chat, which is supposed to be ChatGPT, and Bard, which is like that Google GPT, and it generated these two sentences that they generated. I think I paraphrased it anyway, but yeah, it's really bizarre how it works, because one of them I did it on a live stream as well, so you could, because a lot of these things you cannot replicate, because that's another thing. Sorry, like jumping around, but like how reproducible your result should be. So if you use like a fancy neural network or something, then how do you know? Whenever you get an answer, like how do you get it? Like, is it important for it to be deterministic? So say every time you see a certain signal, that it will detect it with a certain error margin. So if you wanted to do that, you would, yeah, probably like a fuzzy logic would be a way to go. Because yeah, this is just an example of where you um, have an input wave, and it's going through an algorithm, and it's detecting that that you input the input is square and the output is square. But once you start increasing the noise, then it starts making mistakes. So it's just jumping around between saying I don't know what it is, but just around 60%. So you already have like about with that much noise level, you have essentially below chance level. Well, chance level. Anyway, you have the performance significantly reduces when you increase your noise. So I don't know. To you, it still looks like a square. I don't know, or maybe it is, maybe it isn't. I mean, because you also know what it is. But the algorithm makes lots of detection errors. It's when it says it's actually something else. Yeah. So you see, it sometimes says it's a right trapezoid for whatever reason. So it sometimes confuses this signal signature for something else. And when you go noise even higher, it will just start. It just stuck in unknown. So it's essentially 100% wrong, like 100% error. Or sometimes it still indicates it's a square. So it's not 100%. It's like 96 or something percent. So I'm just saying, if you had something like if you did your evoke response potential, and you had a very strong signal in there, like every time you stimulate you get a strong response, well then you probably don't need to. Yeah, I'm thinking about like having another tool where you put this on a distribution, a like comparing two distributions, like on in a two-dimensional space, like in a one-dimensional space, just two, or have them in two-dimensional space where you have the distributions, like, and then you see how much overlay there is, or is it? So if there is no a overlay, you could just put a line through them and do your detection. That way you don't need to clean to reduce the noise. Won't be necessary. Just find the bug in it or something. So where did the red thing go? Just disappear on me. I know it is there. And I was saying before that this signal, the square, for whatever reason, well, I guess you could explain why, but it's easier to detect than, say, a left triangle. So the left triangle, this thing will go, well, yeah, jump up. So if you had the noise of just around 1, which in this case it's not like an absolute value. It's just a relative to the signal strength, right? That's why there's no units to this. Well, so in this case, if you have a performance, why is it jumping around that much? It's a bit jumpy, isn't it? Around 65% error. Ah, I know why it's jumping so much, because of the oops. Yeah, in Lavie you can just go and tick a box for a disable auto scaling, which for this one I'll have to do another another input, another button selector. Um, so we had this API. We want to probably all relevant as well. And we were adding it as so this is calling the API. This is the API itself. Put the better documentation to it. What I got stuck on. First, we need to add we have more of those signals. How do we do that? Oops. No, I want to select that. Want to multiply it several times. And well, actually 3 times. And we can go edit items. Put it on our screen so it's easier to copy. And we have like, then we have token 1, and that's 132. We have token 2, 134. And we have the famous cameraman. It's the image that's used everywhere in MATLAB and other places, I would imagine. 134. And wait, this is not, it's not right. And what, right, it's better. Edit manually. And this one, 132. Rid of that. 133. 127. Yeah, we don't like magic numbers, but it is what it is for the moment. And that didn't work. What's up? Check if the API is working sometimes. No, that's working okay. What's the problem? Why this doesn't work? I'm doing something incorrectly. Let's use less non-gender specific language. Photographer instead of cameraman. Now, why are we getting an error? Numbers correct? Fingerprint 121 or 122. Lake 127 132 133. This one 134. Right, now it's working. It will be nice to select the actual wavelet by name. It would be the next thing to do. Values are not sequential, but midnight was 37. Yeah, it's 37. So there's some being skipped or added. Yep, there's 26, 7. Being skipped. Double. The function real time. That's interesting. It was designed to by default work on a real time target. One sec.